practices in data processing and quality control, because it was a limited number of institutions who were operating these sites. And the notion of these merged observatory data files sounded wonderful to me, to gather all the data from each super site in one place, one file was the initial plan, to use similar nomenclature and metadata and structures for all the files so that we had high-resolution observations that could be compared across sites, and more importantly, that were going to be directly comparable with merged model data files from NWP centers at the same locations. By the time I came on board, a certain set of conventions had already been established as part of the plan. The files were going to be written in netCDF. The variables would be named out of the CIMIP6 table if possible, and if not, we would make up names that kept to the spirit of those tables. The metadata would rely primarily on the CF conventions and on ACDD when that wasn't possible. And the devil's always in the details. And as we got more and more, there was a baby table that existed of what the variables were going to be and what we needed. And as we got more and more into the weeds with it, challenges arose. And in hindsight, there's a lot of parallelism between the challenges in doing this for observatories and in doing it for model output. You've got actually an awful wide variety of instruments or of model formulations. Both of those communities quite naturally have their own customized sets of lengths and time scales that they use. Observatories, you can have duplicate observations. You can have surface measurements and tower measurements and balloon-borne measurements and sometimes remotely sensed measurements of the same quantities, winds or temperature. Or you may put a whole bunch of temperature measurement sites near the ground across a site for various and sundry reasons. In contrast, the models are often can be providing different variables than what observationalists are actually measuring. In both cases, variable names and file formats to some extent depend on the history of the people involved and the institutions involved. Everybody's got their favorite way of doing it. At the observatories, lots of different institutions have put their instruments there, lots of different teams, and they need and deserve credit. With model output, as far as I'm aware, the model output from any one model is probably mostly tied to one NWP center, but they too deserve to be properly attributed for their work. And then we were going to have more than one person making all the MODFs and more than one person making all the MMDFs. And it's worth thinking about why we care about this. It's because the Arctic community, I learned, they're ahead of a lot of the other folks in the atmospheric sciences, as far as I'm concerned. They believe in fair data, findable, accessible, interoperable, and reusable. I loved that this was a thing when I came to work with you all. So there was this baby table, and over time, Siri Jodha, who has a lot of experience in the intellectual underpinnings of things like data vocabularies and schema, and me, who had all this frustration and homegrown solutions to not knowing what my data really came from. We ended up being the keepers of what Tennille started calling the Hartten Khalsa table. And earlier this year, we published this table in its current form on Zenodo. Doing it on Zenodo enables us to update it as more people become entrained into the project and more people test it and find things we've missed. It's available in both PDF and JSON formats. If you want a piece of current lingo to toss around, you can think of this as being inclusive. We don't want to discriminate between people's eyeballs and machine scripts. Everybody should be able to access the table. The table describes the desired global attributes for the file. It defines all the variables and all the recommended attributes that each of them should have. And it lets all the MODF makers and all the MMDF makers use their favorite software and to access the current requirements to make these files. The table is set up in 4 sheets for human purposes. The machines probably don't care. The first 2 contain instructions and contain a lineage of where things came from, where you can find the vocabularies we use, things like that. Then there's 1 sheet that's devoted to the global attributes. And a lot of these have to do with the history of the data and the attribution of it. The 4th sheet is the biggest one, and that contains a listing of all the observatory and model variables that we know about that people think they want to put in these. And we explicitly call out the long name attribute and the standard name attribute because those are the first things people want to know, I think. Also the units. And then we have minimum recommended attributes from the list that we're asking people to provide. I didn't use the word earlier, but a slide earlier called this a community effort, and I think it really has been. It's relied on the visionaries, who I'm not going to name because I'll probably forget some of them, miss them, and the detail-oriented, and I'll name myself because not everybody wants to be named as being really picky about details, but what the heck. But the users have also been key. The observationalists and the MODF makers, Laura Huang and Jareth Holt, beta tested my draft JSON files and wrote up these lovely detailed reports of everything that their computer code choked on, which was a big help. Sarah Morris and Elena Akish have developed an Excel template that enables people who are making MODFs to keep track of all the attributes they need and make sure that they actually have found them and have them written down in a place where they can find it again. That's been published on Zenodo as well. And Jareth Holt, in collaboration with Michael Gallagher, has written an MODF checker. It also works, I believe, mostly on MMDFs, and that compares the HK table to the merged data file to see if people have used all the proper things. It's kind of a little quality control, I guess. And the modeling community, those users have also contributed to this. Johanna Tjernström is going to be talking about the plotting tools she's developed, and an hour ago you could have found us talking about some of the things that are causing her trouble with the HK table and that we're going to find ways to fix. So currently, earlier I showed maps of the super sites in the Antarctic and the Arctic regions. Currently, we have 7 MODFs, all in the Arctic. In the near future, not this month, maybe next month, there's going to be another version of the HK table because we've accumulated a lot of little things that need to be fixed up. There are papers in preparation, an MODF concept paper that will explain this more fully to the community, a paper about the 7 MODFs we already have, and a preliminary analysis of MODF versus MMDF files. So I have no idea how fast or how slow I talked, but Gunilla's not standing here at my heels, so I have some time for questions.
So how many variables are at the moment included in this HK scheme?
I was afraid somebody was going to ask. Let's say it's on the. I was afraid somebody would ask that because I haven't counted them lately. I think it's on the order of 150. And the table, to help us humans, the table is divided thematically as you look at it to help us humans find the variables we might be interested in.
Very importantly, there are not just atmospheric variables. We have got terrestrial, snow, ice, and ocean variables are already in the HK table, anticipating that we're going to want to do these coupled studies.
Can you repeat that into the mic?
Okay, so without my mask. I said really importantly, Leslie and Siri Jodha have populated this not just with atmospheric variables, but also with snow, ice, land, and ocean variables, because we're living in a world of coupled models, and we're going to have to be looking at coupled processes. And even though these YOPPsiteMIP sites were all on land, we knew that Mosaic's out there, and Mosaic's got all these ice and ocean things that they're going to be wanting to integrate in.
If people want to participate in this, you can find me and Siri Jodha and and suggest more variables, but then we might be expecting files from y'all. Yes?
The important point is that the timing, sometimes you can have measurements with instruments that can have not the same frequency. Any guidelines or
Yes.
suggestions for this?
So the question is about the timing of the observations, but the answer is applicable to both timing and vertical resolution. The modelers from the very beginning expressed an interest to have very high resolution observations, and there is an ethic of observationalists should provide the highest cadence variables that they are comfortable releasing. So you may measure something at 100 hertz, but you wouldn't actually let anybody look at it unless you'd averaged it down to 1 hertz or something, perhaps. So that's okay. Like the flux, flux people take high resolution measurements sometimes and then average, give you 10-minute fluxes. So the files are constructed, you can have multiple time variables. And so if some of your data comes at 1 second resolution and some comes at 1 minute and some comes at 10 minutes and some comes at 30 minutes, you've got different time variables to use as the dimension for those fields. And there's a similar setup for height, where you can have, whatever your instruments on your tower, wherever they are, you can have a height variable that holds all those different heights. And if you don't have the same instruments at all the heights, that's okay too. You just use that height as a dimension, that tower height variable as a dimension, and then you populate your two-dimensional height versus time field with the temperatures you have and the winds you have and the fluxes you have somewhere else. Does that make sense? Yeah, okay. I tried. Talk to me. Okay.
Thank you, Leslie.
Is there a time for a question or no?
Well, yes, go ahead with a short question.
Well, first of all, thanks really for your work on this, because, it answers also my question to Johnny earlier, that in Antarctica, with Antarctic YOP, we would like to follow up and apply this MODFs to Antarctic measurements. And actually, my question was similar, but I think you answered partially. But how adapted is it to raw and post-process data? Do you try to take into account all the different stages and use it for as much as possible for raw measurements and then different stages of post-processing of the data, or it's fixed to some higher level post-processing already?
I guess that is left to people's judgment. And we are not a 110% unified community. I tend to fixate a little bit on what the initial mission was. And the initial mission was to allow modelers to do process studies with NWP models. And so they were thinking cadences of, I don't know, 5, 10, 15 minutes, for instance. And if you want to do the process study, you want to do it well, so there's some post-processing. You want the modelers to have to not do a lot to it, but on the other hand, you want the modelers to be able to do it before they retire, so you can't spend a decade tuning your data possibly, you know? And I think we did start out with notions of the level of quality control we do, and some of that just got tossed to the wind because we didn't have the people and the ability to quality control some. Not a satisfying answer, maybe, but